In this video, we're using what we learned in triangle similarity, and now we're applying it to the real world using a method called indirect measurement. And so indirect measurement is used in order to help us measure things that would otherwise be difficult to measure with traditional means. Some of you in class may have heard that we tried to measure the height of the school, and a lot of you said using a tape measure and throwing it over the side. Well, that's unreasonable because the school's a lot taller than your standard tape measure. So you would have to tie multiple tape measures together or buy an extremely long tape measure and hope that you could run it down the side of the building and get an accurate measurement. So instead, what we said to do was to measure a shadow along the ground because it's a lot easier to measure things along the ground than it is to measure things vertically. And that's the kind of problem we have here in example 2. In example 2, we read and we see the lead statue of the Korean War Memorial in Washington, D.C. casts a shadow, so along the ground, of 43.5 inches. Notice that I'm paying attention to the units as well as what it was. At the same time, a nearby tourist casts a 32-inch shadow, so now we have two shadow pieces. If the torus is 64 inches tall, notice I'm switching colors because this is not about the shadow, and it wants to know how tall is the lead statue. So when I do that, I can set up my fractions based on what it asked me. I have 4 key things that it mentioned. It mentioned a statue and a torus. So I can have statue, torus, but it also mentioned shadow and tall. So as you see, I now have kind of a grid here where I could fill stuff in. So the shadow of the statue was 43.5 inches. The shadow of the torus was 32 inches. The statue's height was unknown because that's how tall is the statue is what we were looking for. And the torus's height was 64 inches. So now we have our table set up so we can go in and we can try and simplify anything that can be simplified. So we have 43.5 over x is equal to, well, I can divide both of these by 32 to get 1 over 2. And when I cross multiply now, and use my butterfly method, I get 43.5 times 2 is equal to 1 times x. So I end up with x is equal to 87 inches. And that makes sense because if I look at my picture and if I want these two things to be similar, then my height needs to be bigger than the shadow because the height of the torus was bigger than the shadow. So that's an easy way to check real quick to see if my answer is correct. And it turns out that the statue will be 87 inches tall. Down here, if you notice, I don't have my triangles separated, so the first thing I would do in this problem is separate out your triangles so that you can see what's going on. So we have VWX, which is 3 and 5, and then we have, sorry, it's not the best picture, but we'll make it work, 62D. We have V, Y, and Z. And notice that they gave us a similarity statement. So since they gave us a similarity statement, the actual picture doesn't even matter. We're trying to find D, which is on the side YZ. So that's my first fraction. We have YZ. And if we go and we look, that's going to be triangle VYZ over triangle VWX. Let's move this guy. So what that means is I need the pair that goes with YZ. Well, YZ is the last two letters, so this is going to be WX. And then I see that VY is going to be my value side, which means that I'm going to need VW because VY is the first two and VW is also the first two. Once I do that, I can plug in values. YZ was D over WX, which is 5. That equals 62 over 3. I can't simplify anything at the time, so I'm going to have to cross multiply. And I end up with 3D is equal to 62 times 5. 3D is equal to 310. D is equal to 103 1/3. And so that is the depth at which the water is if it's 62 meters from the shore. And that's how we do indirect measurement. We still set up our triangles and we just set up fractions like we did with similarity, and we finish out the problem.